Okay, we can start now. Good evening, everyone. We are delighted to have again with Mr. Gaurav Kumar with us as keynote speaker. He is founder director of Magma Research and Consultancy Services Haryana, and today he will be taking simulation tools for smart cities. How simulation tools are used to model, analyze, and optimize smart city infrastructure and operations for improved urban planning and decision making. Uh, so he will be covering these areas in his address today. So let me introduce once again Mr. Gaurav Kumar. He is a resource person, speaker, trainer for various workshops, seminars, webinars organized by AICT, Atal, TQEP, FDPs. He is also a resource person for STCs. So he also do very hands-on sessions in areas like cyber security, data science, AI, IoT, blockchain, quantum computing, and digital marketing. He has experience in various research tools, technologies, and their practical application. Beside this, he is author, reviewer, and editor for international journals and magazines, and is a holder of registered design under the Design Act 2000, and is certified by IBM, Google, Accenture, and TCS. And freelancer, also works as freelancer in research tools and technologies. So, sir, you can start after that. Okay. The
Okay,
stage
ma'am.
is all yours to begin the simulation tools for smart cities.
Good evening to all the participants. We are starting today's session. Dear participants, dear all, I have shared my screen. Kindly confirm whether screen is visible and you are getting audio clearly.
Yes, 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 sir. You can go ahead. Everything all right.
Okay. So, dear participants, in this session we will discuss about different tools, different platforms for simulation of smart cities, that is part of Internet of Things, Internet of Everything, not only in IoT, but nowadays we are in the era of Internet of Everything. In Internet of Everything, there are merger of different technologies like Internet of Vehicles, different sensors, gadgets, cloud platforms. So in this particular session, we will see how to integrate different platforms for such simulations. And in smart cities, we will take particular focus on smart vehicular networks, smart traffic simulation. You might have seen that for in implementation of IoT, and in IoT, if we discuss about vehicular networks, that is part of smart cities, then very traditional toolkits, very traditional platforms are used. One of the very popular platform is MATLAB for research simulations. If we have seen that many participants work on some other open source toolkits, as far as a MATLAB is concerned, it is proprietary software. But in contrast, lots of free and open source toolkits available. But those toolkits are quite challenging for specifically for new researchers like NS2, NS3. In case of NS2, we have to work on TCL scripts. In NS3, we work on Python. Some other programming languages we can integrate, Omnet++, OpenNet. But as far as NS2, NS3, MATLAB, these platforms are concerned, these are very generic in nature for implementation, for simulation. Generic means, for example, I want to work on vehicular networks in smart city. I want to simulate drone application. I want to simulate a particular application in which there will be some particular flight controllers. There will be some weather. integration, that in this particular temperature what will be the scenario of that city of vehicular network in summers, in winters, in specific weather area, in specific weather condition, by which way this network will behave. So these features are not available by default in MATLAB, NS2, Vylenta, Qualnet. As all of you are researchers, you are already working on IoT and different scenarios, you might be knowing it very well that in case of NS2, NS3, MATLAB, Scilab, Vylenta, Qualnet, we work in generic way. Generic way means broader way. If I want to take, for example, some aircrafts, so this feature is not available in NS2. We have to integrate only node, IoT node or sensor node. Okay, and we assume that it is a car, we assume that it is a drone or flight or something else, only on basis of some assumptions. Nowadays, lots of platforms available which are dedicated to specific scenario. Okay, some of these I am showing you here, and very soon I will start demonstration part. Kerala, City Flow, and all of these projects, all of these toolkits are completely free and open source. Open source simulator for autonomous driving research. If you want to work on internet of vehicles or VANETs, actually if we move back to 5 to 6 years or 10 years, then lots of research were going on in segment of vehicular ad hoc networks, VANETs. But nowadays, VANETs are transformed to IOV, that is Internet of Vehicles. Because in vehicles, in cars, in different moving objects, we are using GPS system, we are using FASTag, we have advanced technology, we are connected to satellite. And as far as current scenario, as far as current implementation is concerned, you might have seen that FASTag system is also getting upgraded. In upcoming time, in upcoming few years, you will see that there will be no FASTag toll plaza. Automatically via satellite, by distance covered, how many kilometers you have covered, automatically depending upon that, payment will be deducted. So in current scenario, rather than working on classical platforms, we have to move to dedicated platforms for smart cities, vehicular networks, and in area of internet of everything. Cup Carbon is there, Sumo, Eclipse Sumo, simulation of urban mobility. So what is benefit of these? Which are key benefits of using Sumo or Cup Carbon or Kerala rather than using MATLAB or NS2? Okay, first of all, I want to say that we are not against any particular software suite or any company. Okay, if you are working on MATLAB, that is fine. If you are working on NS2, NS3, Vylenta, Qualnet, or whatever it is, OpenNet, OMNet, that is fine. I am giving you some alternatives. I am suggesting you some platforms which are easy to use, graphical user interface based. So you can see that this type of interface you will get. You will be able to simulate cars actually, rather than only moving nodes, rather than only some specific generic nodes. Using this particular toolkit, using multiple free and open source platforms, we will be able to integrate very effective implementations for our research work. If you want to create a scenario of flight control, that can be done. If you want to implement a particular vehicular network or congestion control near to a roundabout, you might have seen in metro cities there are so many roundabouts. So we want to work on congestion control near to that. So we want to put some traffic lights. In case of NS2, there is no option to integrate traffic light, some particular red light or green light. or some particular roundabout. For each and everything, we have to work on script. But nowadays, very easy to use toolkits available for such implementations. Okay, in this particular session, we will cover two platforms, Cup Carbon and Eclipse Sumo. Okay, so as far as detailed scripting is concerned, detailed implementations are concerned, we will focus on Cup Carbon simulator for smart cities, smart vehicular networks, and after that we will shift to Sumo. Okay, and then you will be able to decide which platform is better for your research work. Okay, so Eclipse Sumo. So this type of scenario we will be able to create, and so you can see that which features are available: traffic management, traffic lights. You will be able to import different types of networks. Okay, you can integrate it with Google Map. So you can see OpenStreetMap. Any specific area you can take. For example, you want to take uh, traffic of your nearby city, for example Shimla, New Delhi, Chandigarh. I want to take that particular longitude, latitude. It can be done. In NS2, NS3 it is not available. We can't integrate real time GPS system. Okay, so you can see that all of these are features and completely free and open source. Okay, so I will cover it. But before this tool, before this particular platform, we will cover very easy to use free and open source toolkit, that is a Cup Carbon for simulation of smart city. And in smart city, how to work on smart vehicular networks, urban mobility, and it is compatible with multiple programming platforms with different types of chips. So as in previous session, previous coverage, you were viewing some implementation related to MATLAB, ThinkSpeak, sensing data. So ESP32, ESP8266, that can be integrated. Okay. So whether you are already working on some toolkit, you are already working on Arduino or Raspberry Pi, you can link Cup Carbon with that. And in any programming language, in whatever programming platform you are comfortable, you can link. If you are comfortable with Node.js, okay, Cup Carbon and Node.js compatibility is available. If you are comfortable in Julia, that is widely used for machine learning and data science, Cup Carbon and Julia connectivity is available. By default, it is compatible with Python. Okay, Python connectivity, Java. This particular software is developed in Java, but its interfaces are available for Julia, Python, and Node.js. And you can see that it is having its own scripting language that is known as a Sanskrit. If you are working on smart vehicular network, urban mobility, and your work is related to advanced wireless protocols, advanced wireless generations like 5G or 6G. Okay, you want to give a new flavor. You might have seen that when we go for research work, then we try to integrate multiple technologies. Okay, if we will say that I'm working on VANET, I'm working on Internet of Vehicles, then DRC panel or RDC panel, they will say that, okay, what is new, what new you are doing. So if if we want to integrate 5G technology, 6G technology, that can be done. Okay, so integration of IoT nodes, Python, C, Java, C++, it is having its own programming script, that is a Sanskrit, ESP32, MQTT. In previous session on 16th, we have discussed about this protocol. We can integrate message queuing telemetry transport MQTT with our cup carbon simulator. Okay, we can link it with Android also, Android, Raspberry Pi, and other devices. And you can see that this type of interface will you will get very easy and user friendly, very professional user interface you will get, rather than some nodes, rather than some classical dots or classical buttons. Okay, so you can see that it is integrated version of IoT as well as advanced wireless sensor network. If you want to work with Zigbee, you want to work with LoRaWAN, you want to work with different platforms, so you can see Wi-Fi, Zigbee, LoRaWAN 802.15.4, all of these can be done. Okay, as far as its specialty is concerned, it is meant for smart city and IoT wireless sensor network. Okay, integration with different toolkits that we can do. Okay, that we can work with. Is this clear to all of you up to now? Are you getting content, audio, screen clearly? Kindly confirm so that we will move ahead. Everybody getting screen as well as audio clearly.
Yes, sir.
Okay, so dear participants, now we are starting the demonstration part. Okay, so you can see its detailed documentation is available, tutorials are available, Sanskrit, its forum in which we can put our questions, we can go for troubleshooting for our implementation. For example, we are stuck at a particular point and we need troubleshooting, we can go for that. Now we will see how to work on this platform for simulation of smart city, smart vehicular network, and urban mobility. Simply we will download it. Okay, so you can download it. I will not download because it is already downloaded in my system to save time. Okay, so very lightweight software, this one. So you can see that this is cup carbon 6. It is only a jar file. Okay, so I am opening it. I will show you how to work on this simulator. This is a jar file. When you will download cup carbon software, it will be downloaded in form of a zip file. Okay, when you will unzip or extract that zip file, you will get this jar, cupcarbon.jar. It is a Java archive and self-executable file that we can work with. Okay, it is Java based software, but its interfacing is available for multiple programming platforms. As far as its variants are concerned, okay, its multiple variants are available: cup carbon 6, cup carbon 5, cup carbon 4. We will work on two variants: current variant as well as previous variant. In every variant there are specific specialities. Okay, so first of all, now I am opening my command prompt so that we will be able to work on this simulator. Okay, I am opening command prompt only to execute it. No need to worry that I will write some script. Okay, so this software is on my desktop, and okay, Java jar, and I'm running this tool. So you can see that this one, this is working panel and dashboard of cup carbon simulator for urban mobility for vehicular networks. Is this visible to all of you? Is this screen visible to all participants? So I am placing it in this way so that I can show you something. Cup carbon twin
Yes, sir.
IoT 6.52. Okay, so I have placed this simulator in this way, and at right hand side your messages are visible because I want to view your messages also. If in between the session, in between the demonstration, if you have any query or there is some doubt, you can put your questions. Okay, if something is not visible, so I have placed it in this way so that I can view your chat message as well as this particular simulation. So you can see that this one is cup carbon we have executed, and it is giving us very professional interface. You can see that by default it is giving me this particular interface of Google Earth. Okay, so map, in which format I want to view it, in form of Google Map. So you can see in map menu, Google Map, or if I want to, for example, I need some vehicles, I need some cars, some particular moving objects at a particular screen is visible to all of you. There is one message from one participant, not visible. Kindly confirm whether screen is visible to all of you.
Visible, sir.
Uh,
Visible, sir.
one participant, so I request participant to pin it. Okay, so you can see that this one is view of Google Earth. In map menu, you can see that this is satellite view. So you can see that this type of interface, this type of working scenario is not available in NS2, NS3, Vilenta. For example, I want to work on this particular segment. I want to put some vehicles here. I want to put some flights, some drones, and I want to see how much congestion is there or what will be the effect of my implementation. So we can work on that. Okay, map, Google Map, or simply lines. In whatever way we are comfortable, we can work. Now you can see that it is giving us a complete GUI panel, network information, which how many sensors are there, number of sensors currently 0. Okay, so we will integrate some sensors, which devices we want to integrate, device parameters. Okay, radio parameters, which particular radio signal we want to work with. You can see 802.15.4 Wi-Fi LoRa. Okay, any of these we can take. Okay, now I have put this screen in full screen mode, so you can see 802.15.4 Wi-Fi or LoRa. Any of these we can work. Marker parameters or simulation parameters. And you can see that at top we have a toolbar. So this one IoT node, on mouse over you can see IoT node, Python path. By default this platform is compatible with Python scripting. So obviously Python should be installed in our system, and after installation of Python we have to link it with cup carbon simulator. So by which way we have to link? So you can see that this Python path, I will click here, and this is Python. Okay, so I'm showing you in my system. For example, I'm in command prompt, I'm writing Python. Okay, it is added, it is already integrated in my path. Okay, so when we install Python, then automatically path is set. So with Python command it is running, it means that its path is set. So same path we will put here, Python. If I am working with Python in my command prompt with Python 3, in that case I will write here Python 3. Okay, but in command prompt with classical Python it is working, in that case it is okay, we will write here Python. Julia path, this one Julia, Node.js. If I want to integrate with Node.js, if I want to work with Java, I will write here Java C. Okay, so executor path configuration we will set and we will work. Now very simple demonstration I will show, one by one we will see. Okay, starting from hello world to movement to mobility. So some particular Google map. So if you want to take some specific area, you can take. For example, this one is near to roundabout or traffic lights. Now this one you can see IoT node. Click here. This IoT node we have clicked. We have integrated here two IoT nodes. Okay. So with this IoT node, so you can see IoT node we have linked. So you can view it in this way. So by which way you want to view it? Map or this one? Map, Google Map here. This is my IoT node. Now I want to convert it in form of a ship. If I'm working on a marine network, if I want to transform in form of a car, so plus J, so you can see that I need servers, I need cloud. This one is ship, drone. Okay, with specific scenario. So I'm doing it in, with J. Okay, car. This one is car. Okay, if I want to use some specific objects in this way, so simply we will add some specific objects, and all of these objects or some of these objects I want to change. So you can see this one. Drones or cars. Very simple. In if we are working on ns2 ns3, you might have seen that only to create an object we have to write script, we have to create object, we have to call a class, and after that it will be created. Okay, but here everything is done with the drag and drop. Okay, simply click here and put. Now on by pressing J on keyboard, it is changed. For example, we have some marine network. So this one is ship. This one is car. Okay. Now I want to associate a script with this car, with this particular vehicle. So I will start with hello world. Okay, only printing a message. Very easy to use. After that, I will show you some mobility, MQTT, and so many other things. But just to make you comfortable, we will start with hello world. Okay, so you can see that this one, weather. If I want to put some weather condition also, so it can be done. Weather. One vehicle is there and some weather condition we want to put, that can be integrated. Okay, so you can see this one is the icon. Program. I want to put a script. I want to associate a code with this specific car. At left hand side, you can see this one is ID, longitude, latitude, elevation, and energy max. If I am working on energy optimization, so what I will do, I will put initial energy here. And after running, we will see how much energy is remaining. So we can check, okay, at initial time, this was the energy level. At current time, this is the energy level. So whether energy consumption is improved or decreased. Okay, so on click of this program, okay, so I'm highlighting this part, this one, this. Simply click here and we will create. So for example, this one, we are taking one project, and any of these we can take. Now click here. On click of program editor, you will get this type of interface. Now I want to write hello world, simply printing a message. So different codes, different scripts are already given. For example, I want to work with MQTT, so subscriber publisher. In case in previous session we have discussed about subscriber publisher. If I want to write code of subscriber, click here. So you can see that This one is the script, Python code. It is already given. We have to give our credentials. We have to specify our details only. Okay. If I want to go for publisher, this is publisher. I want to print a message, hello world, this one. Okay. This message we have taken and save hello.py. It is a Python file. Okay, Python code, save, close. Now I want to associate this particular vehicle, this object with this file. At left hand side, script file. Whatever script file we have created just now, click here. Click here. Now hello.py. It is integrated, it is attached. Okay, now simulation parameters. At bottom you can see simulation parameters. This one, arrow speed. What is the speed? Okay, so this one, and now run parameter, run simulation. Okay, this one. So whatever script you have written, so results, this one. This, and we are taking to this one. .py, save, and we will associate. So any icon we can take depending upon our requirements. Script file, this, and run. So whatever file we have created just now, we can take. So in this way, so multiple objects we have created, and you can see this one, hello world. In same way, for example, one more simulation we have created, and stop, hello world, and carbon 6. This, some of these icons we want to remove, and this one. So if we want to view that particular code, so on click of this, okay, so each and every code is already available. If we want to go for blinking, for example, blink of some specific node, okay, after that particular blinking we will go for simulation of movement. If we want to go for mobility, okay, so for example, this one, lines, this IoT node, this one, okay, program blink. So we can take this particular blink .py, save, associate, script file, device parameters. In left hand side, device parameters, BL. Radio parameter, in which particular radio standard we want to work, Wi-Fi, LoRa, or whatever it is. Okay, now run. You can see that on run, blinking. Multiple objects, if you want to integrate, that can be done. For example, this one. Okay, so we are selecting it, and modifying device parameters, blink. Is this visible to all of you? Kindly confirm whether the screen is visible to all of you. So very simple demonstration related to blink, related to that particular movement. So it is just to make you comfortable in this platform, so that we at least we can start. Okay, so IoT simulation running, it is showing, and stop IoT simulation. Okay, so this is only that particular blinking part, and now we want to work on one implementation related to message queuing telemetry transport, MQTT. In previous session, we have discussed about MQTT protocol, and some scripts I have already generated so that we can see the results. Okay, so new project, MQ, any name we can specify, desktop. We want to create some nodes as subscriber and publisher. For example, we have some particular vehicles, okay, vehicular network. Okay, these three vehicles we want to
Excuse me,
use.
sir.
Yes,
Excuse me, sir. Which key you are pressing
J.
for it, sir?
I'm pressing J key.
Thank you, sir. Thank you.
Okay, so for example, so first of all I will show you its mobility part. I want to show mobility. Okay, after that I will show you MQTT part. Okay, so these vehicles I have integrated, and one particular server I want to take for IoT broker. Okay, for example, this one is IoT broker. Any of these we can take. This one is broker, or this one is some particular base station. Now we want to give mobility to these three vehicles. Click. Okay, move. GPS locations are generated automatically. If we want to edit it, it can be edited. Okay, from Google Earth, Google Map, we can take some longitude, latitude. Save. To these three vehicles, we want to give that particular script file. This one. Okay, this, and you will see the mobile nodes. So in this way. Okay, I'm opening that particular code again that I have just shown you. One vehicle, Okay. Desktop. Okay. Wherever your gadget is available, it will be in movement. If we want to work with a particular implementation related to transmission of signals, so I'm showing you that particular part because in very short time span it will be difficult to cover so many things, so I'm directly moving to that particular part that will be very very beneficial for all of you. So I'm coming to that particular part. Java jar cup carbon. Okay, and this particular implementation you will see it will look more realistic related to vehicular networks. I will explain its code also. For example, this one. First of all, I will explain. I will show its running part, its execution part, and after that, I will explain how to create this type of scenario. See this very carefully. What is this particular scenario? This one is marker. Marker means this one, this particular location we have specified as a source to destination, source and destination, or GPS path for a vehicle for a mobile node. This one is a base station. As soon, and this particular simulation is related to toll plaza. For example, a mobile node, a vehicle is moving in this particular path. As soon as it is coming near to this particular base station, this specific base station or traffic controller, it will transmit data to upcoming node. So these four nodes, these four stations are interconnected. Okay, first of all I will show you its implementation. After that I will create its scenario from scratch. Okay, so how to create this type of path. First of all I am running it. Execution. So you can see that this is mobile node. This particular mobile node you can associate with a vehicle, so you can take it as a car. As soon as it will come near to this particular base station, this particular controller, so this signal will change. You can see that currently it is B, and as soon as it will come in that particular range, it will be transformed to A. So you can see that as soon as it will come in that particular area, you might have, so you can see that it is converted to A, this particular signal, because sensing is done. Sensing of new vehicle or air traffic control, you might have seen in case of radar based application. As soon as one aircraft comes in range, in a specific radio range, signals are transmitted to other controller or satellite that this particular vehicle, this suspicious vehicle is coming in that specific range. Okay, so such type of scenario if we want to integrate, if we want to work with. Okay, this one, if I want to change its speed, so this one, and you can see that. So if I want to change its location, so you can see so currently it is in this particular range, so all of these are interconnected. Okay, so as soon as it will be in this particular specific range, then this signal will be modified. And by which way this programming is done? Using same script. You can use Python, you can use Node.js, or whatever platform you are willing. So you will see that as soon as it, so now this message will be modified, and you can see that this type of these lines, these arrows are also highlighted. So this type of professional simulation, this type of implementation is not available in other platforms, in other classical toolkits. Okay, so inlines. Now, by which way we have to start? By which way we have to create this type of scenario from scratch? Simply new simulation. Okay, so this is our fresh dashboard. So at top you can see marker. I want to create a path. This one is my path. Okay, 2, 3, 4, 5. This is path. This is GPS path for my vehicular network, for my car, or whatever it is. Okay, now you can see that select all markers. Click. I want to create some milestones. In case of vehicular network, in case of traffic, we work on milestones. On press by pressing U, 1, 2, 3, 4. How many milestones we want to create? So you can see that if I want to create some zigzag path, it can be done. Now my vehicle will move in this particular path. I want that my vehicle or my moving object should move in this path. So first of all, I will have to create its GPS file. So you can see here marker parameters, file name, route1.gps. So this one is route1.gps from city 1, city 2. This is city 1, this is city 2, or this is source or destination, from source destination. Okay, save. This GPS file is created. Now I want to add a mobile node. You can see here mobile node. Click here. Click mobile node. I want that this mobile node or this vehicle should move in this path. In this particular path, this vehicle should move. Device parameters, GPS file, route1.gps, whatever GPS file we have created. Click. Now this particular path, this particular file is associated with this specific node. Okay, now I want to create some base stations, as in that particular session, that particular implementation we have seen. Okay, sensor node. Click. This is first sensor node. On pressing minus sign, so sensor area I want to increase or decrease. This is my sensor area. How much sensor area, how much radio area I want to associate? This one. One more sensor node. Click. Okay, so this is in this particular range. So two sensors I want to integrate. So obviously it should be in this range. If I want to increase range of this sensor, okay, so you can see that shift plus. So everything is GUI rather than working on some particular TCL scripts or anything else. Okay, by simply creating this one more base station I want to create for my radar application, this one. Okay, and this one. Now I want
Sir, where can we find these shortcut keys to increase the range, or
I will,
you are telling?
ma'am, I will give you this presentation in my PPT. These things are given, so you can see that in this presentation I have given everything. Is this visible?
Okay, thank you, sir.
I will give you this PPT at end of the session so that you will be able to follow it. Okay.
Thank you, sir.
During this session, I am covering everything in demonstration mode. Okay. So
Thank
once this is created, so that particular implementation, once it is created, after that we can work with that specific part. Okay, for example, mobile routers, multiple routers we want to create in same way. So this one, so this zigzag path we have created, so here it will be zigzag path, and I want to integrate some weather condition also. So you can see this one is natural event generator. I want to generate some weather condition that in this much temperature, what will be the behavior in that specific temperature, what will be the behavior. Okay, now after that, run, and it will be executed. Okay, so many windows we are opening. So I will give you this detailed presentation in which every screenshot is given, and you will be able to imitate it. So multiple base stations, and after that we will be able to work with that specific simulation part. So as we have seen previously. Now there is one link here. So if we will execute this code for 20 minutes or 30 minutes, we will get this parameter automatically: battery level consumption, battery level average. So in case of ns2, ns3, other platforms, we have to calculate it manually by tr files. But here you can see that its energy consumption level is already given. So if we will execute it for uh, multiple attempts, in that case we will get these graphs automatically.
Excuse me, sir, Gaurav, sir. Sorry for disturbing you, sir.
Yes, ma'am, please.
It is depending upon the energy consumption is based on the vehicle parameters. No, now how can we check the vehicle parameter for parameters?
Okay, ma'am, actually, so you can see that here, as I have shown you previously also. So the radio parameter. So you can see this one, listening energy. Is this visible, ma'am, at left hand side?
Yes,
These
sir.
are,
Yes, sir.
so ETX, transmission radius, what is data rate. So what we can do, we can give initial value. For example, I want to take initially from 2000, okay, 2000 units. Data rate is this much, okay, and
What
after.
is data rate, sir? What is data rate?
So what is our bandwidth? How much bandwidth we want to use? Okay.
If it is a vehicular movement, for vehicular movement,
Yes.
showing for a vehicle it is moving, the much energy, how much of energy is lost, what is the battery consumption, everything correct? You are saying.
Yes. Yes. Yes.
So
Actually, for every, for example, one node we have selected, and I want to give this sleeping energy. So I will give 1000, and I will click here. I will
okay,
put, for example, 90, and I will click here. By selecting that particular node, that initial energy will be allocated, that initial parameter will be allocated. And after execution, we will see how much is remaining. And at top, you can see number of packet lost, packet received. So throughput, uh, packet lost, packet received, each and everything is automatically calculated. So at top, you can see here. Is this visible, ma'am?
yes, sir. Yes, sir.
So how many packets are sent? In case of other programming platforms, other simulators, we have to calculate it manually. We have to
Okay.
see, okay, this one is the TR file, and we work on Gok commands or some other commands. But here, each and everything is done automatically. Now, one implementation very quickly we will see related to MQTT protocol. So I'm opening this platform again, and this one. Okay, so related to MQTT, so you can see that this one, subscriber publisher scenario in simulation or lines. Okay, this one. So we have three IoT nodes, and this one is our publisher. Publisher means this one is sending data. These three nodes are subscribing data. Okay, these three nodes want to subscribe. For example, this one is, these are some vehicles or some other objects or systems. Okay, any of these you can take. For publisher subscriber, you can see, click here, py publisher, py subscriber. So these scripts, these are available here. Publisher, broker.hivemq.com, broker.hivemq.com. In previous session I have covered it. What is hivemq? This is MQTT protocol, this is MQTT broker that we work for our that we integrate for our implementations. You can take Hive to work with IoT transmission, IoT signal transmission. We need this Hive MQ, or in last session we have covered MQTT cool. Okay, this one. So it's up to you whether you want to this one, you want to integrate this one for data transmission or Hive MQ. In this implementation I'm using Hive MQ. Okay, so this one, Hive MQ. Publisher, and you can see that broker.hivemq.com 1883. So these settings I have put. These codes are already available in the study material I will share to all of you. And this particular code for subscriber, and topic name is cup topic. Okay, any topic you can specify. These we have allocated. Now simulation parameter and execute, and you will see very soon that this one send 0, this one send 1, and received 1. You can see that. Is this visible to all of you? So this particular device is sending data, so it is sending 1 and 1 is received. This one is sending 0 and 0 is received. So you can see that this one. Okay, send 0 and 0 is received, send 1 and 1 is received. If we want to integrate some weather condition, so you can see that this one, and natural event generator, on click of this natural event file, if we want to allocate, that can be done. For example, I want to work with some, this one, natural event generator. I want to generate weather. Okay, randomly I want to generate different temperatures, different weather conditions. Okay, weather, save. Now this weather I want to allocate with that particular file, natural event weather.evt, allocate. Now in this particular weather condition, by which way it will behave. So send 0, 0 is received, send 1, 1 is received, in same way. Energy parameter, so each and so we have to execute it for more time, 20 minutes, 30 minutes. After that this graph will be filled. In same way, for example, we want to work with another scenario that is also related to MQTT. For transmission, I will send one command from my system. So this one is the scenario, multiple nodes we have integrated. So if you want to change these nodes, you can modify, and I want to send one particular signal. Okay, so first of all, I'm copying that command related to MQTT, this one. Okay, now I will execute it. See this very carefully, what I'm doing here, one script that is related to subscriber. So all of these nodes are subscribers. Okay, so in this also I have mentioned this HiveMQ, broker.hivemq. Okay, so you can click here by subscriber. So on click of this button, automatically code will be generated, and in this particular code you have to put your credentials. So simply broker name, that port number it will take automatically. Okay, so this HiveMQ, and now I'm running it. See this very carefully. What will happen? So I'm placing it in this way, run, and now I'm opening my command prompt. From command prompt, I will send message, or from Raspberry Pi, from Arduino board, I will send message, and you will see what will happen here. So from command prompt, I will send message to carbon. Okay, so this one. Now see this very carefully. From command prompt or from Raspberry Pi, from Arduino, I'm sending message to remote devices. Enter. Okay, so first of all I will move to my mosquito directory. Okay, I will. What is mosquito? Mosquito is the platform. So in last session we have discussed about mosquito. We have to install paho mqtt, pip install paho mqtt, so that we can interface our platform with our external device. Okay, after installation of paho mqtt it will work. So you can see, you will see message will be received here. Okay, message that will be received here, IoT simulation running, and whatever message. So you can see that I have sent message from command prompt, it is received on this. Is this visible to all of you? Received 1. Now I am sending 99. You will see received 99. Received message. Whatever message we want to receive or send. Okay. Received 0. So I have sent 0. And now I want to send 1. Received 1. So from third party, from external platform, we are sending messages, and same message is getting received on this particular platform. In same way, any other object we want to take. One. Okay, from multiple devices, from multiple. So you can see received 1. This one. Okay, so in this way. And how many packets are sent, how many packets are received, throughput, everything will be calculated automatically. To some extent, are you getting these contents? Are you understanding the coverage? Kindly confirm. To some extent, not fully. So this particular platform, carbon. Now very quickly we will see another platform, so that you will be able to so that you will be having multiple options for your work. So this is carbon that we have covered here. It can be interfaced with Node.js, it can be interfaced with Julia or ESP32 or whatever it is. Now other platform, very quickly we will cover Sumo, simulation of urban mobility. We can download it. Okay, simply you can download and start working on this tool. Completely free and open source. Its rich repositories available related to documentation. If you want to work with Google Map, we want to integrate some pedestrian data, traffic data, different types of scenarios can be integrated. This software I have already installed, and after installation of this software Sumo, we have to work with NetEdit. So very quickly I will cover it, so that you will be having its look and feel. NetEdit. NetEdit is the platform to work with Sumo. So this is net edit. I'm placing it in this way. Okay, file, new network, and you will see so many features available in this software. So this one. Now I want to create a path. This is my path. Okay, edge mode, first, second, third. This path I have created. Is this visible to all? Are you able to view this toolkit, this tool? Net edit.
Yes,
Simply
sir. Yes.
drag and drop. So I'm not writing any code. So you can see add sidewalk. I want to add some sidewalks, some pedestrians, some traffic lights. Everything can be done. So very quickly we have done it. Now different tools are available, tabs are available, data. So you can see in demand. I want to take, I want to work in vehicle mode. Okay, click. I want to generate some car. Okay, so trip. I am creating one trip. This car. This is my trip. This car will move in this particular path. This is the path of my vehicle. Finish route creation. At left hand side, you can see finish route creation. Car is created automatically. So you can see now one more car I want to take. This one is the path. Finish route creation. Two vehicles I have integrated. I want to take some traffic light. So stop mode. If I want to take some, if I want to put some obstacle, I want person mode. I want to take some person. I want to place some person so that accident or disaster management can be done. Okay, this one. Okay, route distribution mode. So many features available in this. So you can see show all person lanes. Now two vehicles, one path. Edit. Open in Sumo GUI or Control T. So I'm saving it. Open in Sumo. This is Sumo GUI. At backend we have net edit and it is linked with Sumo GUI. In which mode I want to work? Real world, railway network, selection. Okay, in real world. I want to see this simulation. Run. Okay, so if I want to use it in form of a railway network, rail network. Simulation ended. I want to modify this specific path, this specific network. Okay, so edge mode, traffic light mode. On click of traffic light mode. Okay, so different IDs we can put. Okay, edge chain mode. I want to create a chain of network, a chain of path. Demand. This one is path. I can link it with Python code. I can link it with Java code. Different parameters will be calculated. Okay, so you can see that persons, containers, stops, everything available. Edit. Open in GUI, Sumo GUI. Okay, this one. Real world. 200. it's linking, it's linking with netsim can be done. Okay, linking with netsim, python, java, and after that we will be able to calculate multiple parameters. Okay, load demand in net edit. So rather than working on classical implementations on classical code based platforms, we can work with dedicated toolkits for IoT implementations. Okay. So if we associate it with some particular script, with some particular code, in that case, we will be able to see congestion. We will be able to see whether there is collision or not, whether how much energy is consumed. Each and every parameter we will be able to calculate. We will be able to measure. So this type of professional interface or professional simulation is not possible or not available in other software, specifically script based. Here anything you can type mode. So type mode is available, distribution mode, stop, person mode. Okay, person, you want to place some person here, you want to place some person at this particular point. So in specific scripts, netsim or other, we can work with. So you can see I want to use some bus stop, train stop, junctions. So at left hand side you can see edges, junctions, bus stops, and then we will be able to simulate it very effectively. Okay, person trip, walk, route, all of these features are available. Plan type, which type of plan, person trip or ride or walk. Okay, so it's up to you whether you want to use cup carbon or that sumo or air sim. Lots of
Excuse me,
tools,
sir.
lots of platforms are available that we can integrate for our implementations. Okay, hide junction,
Excuse
direct
me, sir.
junctions. Yes, ma'am, please.
In Cup Carbon, you have shown some Google Maps. In
Yes.
here, there is no such a Google Maps. We have to form the route, correct?
Yeah, actually, yeah, in this case also we can integrate Google Map. Okay, but that can be done via script. Okay, via scripts, via NetSim integration, it can be done.
Okay.
Okay, so you can see integration with XML, visualization. So everything is available. So you can explore these toolkits. So my motive was to make you aware about multiple options available for simulation of smart cities, smart vehicular networks. Okay.
Thank you. Thank you.
Now, dear participants, I am sharing this presentation in which these links are given. A session is open for your queries. If you have any query, you can ask. I am sharing this code, this particular presentation link in chat window. Kindly confirm whether it is downloadable or not. And if you have any query, you can ask. Any query from participants, any point of discussion. And how much these tools are looking adaptable, beneficial for all of you. What about your reviews? What about your uh, point of concern as far as other platforms are concerned? And this one, Sumo, Cup Carbon, and so many others. And kindly confirm whether this presentation is downloadable or not.
Yes, sir. It's a downloadable, sir.
Okay. And session is open for your queries. Last 10 minutes. If you have any query, you can ask any query, any point of discussion. Okay, so you can
How
explore
can
these.
we learn this? Where can we learn this? Because we are in teaching field
Okay. Actually, ma'am,
where
it's
there is a
online
large
documentation
gap.
is available. Is this visible, ma'am? Is this visible, ma'am?
No, sir, no
I
presentation.
have shared. I have reshared my screen. I'm
Yes.
sharing. I have shared.
It's visible.
Okay, so you can see that its documentation is available. If you want to go for its detailed documentation, for example, I want to create a flight network. We want to work on Google Maps, or so you can see motorway pedestrian simulation. So if you want to view, if you want to work on that particular part, so you can see road network. So how to work on that? If you want to work with GPS network, okay, so you can see waterway simulation, railway simulation, bicycle, waterway simulation. So not only vehicular network on road, we can work with ships, we can work with railway network, bicycle simulation. So you can see that this one. So each and everything. So complete documentation is given. Open street map. Open street map. Okay. If you want to work with street map, so as you were asking about Google Map in this particular toolkit, so you can integrate a Google Map also. Okay, open street map, and it will give you an interface similar to Google Map. Okay, so this type of interface you will be able to work with, you will be able to integrate. Okay, one more platform I'm sharing with you that will be very beneficial, that is QGIS. You can link QGIS with your implementations for spatial visualization. Okay, it is also free and open source. QGIS, completely drag and drop based. If you want to create a vehicular network, if you want to create, if you want to generate different types of graphs, different types of plots related to some aerial images and your simulation, that can be done with QGIS. Okay, free and open source. So you can explore this tool, and beyond these also lots of other toolkits available that you will be able to work with for effective implementations. Actually, so why we are covering these out of the way simulation platforms? Because in classical simulation platforms lots of features are not available. For example, I want to work with IPv6, I want to work with IPv6 with 5G or 6G, or I want to create my own protocol. In classical simulators, these features are not available. In classical platforms, it becomes very hectic and challenging to code everything. But nowadays, GUI based toolkits available, which are very effective and easy to work with. Okay, without having any rigorous programming experience, by simply dragging, dropping, and uh, with online documentation we can create very effective plots. And obviously if we are getting these type of diagrams, if we are getting this type of output, then there will be better possibility of our publication, because when we go for research, then major motive is the publication, good publication in highly indexed journal. So good publication in high index journal will be possible if we will able to present our output in very effective way, in very professional way. And these toolkits give you very professional output. Okay, whether you are using cup carbon or you are using sumo or anything else, if you are presenting your output in this way, then obviously chances will be better for good publications. Okay, it's online tutorials available. Okay, so no need to struggle for any specific uh, ebook or any specific source. Everything is available. So you can see cup carbon user guide is available, that is also free. So, dear participants, if you have any query, you can ask any other query, and how much these tools look easy or difficult to work with, your views. If you have any suggestion related to this session, you are most welcome. Any query session is open for your queries and discussions.
Sir, I had the actually same query that you have already answered, because all these tools output that we can use it in our research work, right? So
Yes,
that,
ma'am.
yeah, because you are working as a reviewer editor as well, so you can guide us regarding this, and it will be.
Yes, ma'am. Actually, in case of publications, in case of good publications, we have to go for some out of the box, some out of the way results. Okay, if we will give some classical results in form of tables, in form of graphs, in classical screenshots, in that case, you might have seen that it becomes very challenging and uh, very hectic to defend our work. But if we are using some advanced toolkits, these toolkits, then obviously there will be better possibility of good publication acceptance. And in that, and obviously these toolkits are very useful for teaching also. For example, you are teaching internet of things, or you are teaching VNets uh, uh, to multidisciplinary students. So whether somebody is from mechanical, electrical, or robotics, or computer science, so anybody can learn these toolkits without having any complex programming knowledge or deep programming knowledge.
Yes, sir. Even it is useful for processor architecture as well.
Yes.
I just got that subject.
Yes.
And sir, you have taken all the sessions so nicely. It will be a little difficult for us. We need to see your videos and make a note of all these things and practice. Then only it is possible for us to do
Yes.
such work.
Yes, ma'am, you are most welcome. So if you face some issue, you face some problem, you can contact, you can communicate by mail, and I will try to troubleshoot.
Yes,
Um,
sir. Sure, sir.
the PDF of the today's session is available on the WhatsApp group, Rashmi. If you can see, if you are on the WhatsApp group, it's
Yes,
on the
yes. I have
WhatsApp group.
downloaded, ma'am.
Okay, okay, okay.
Yeah. Thank you,
That's
ma'am.
good. So, any other queries?
Sir, good evening, sir.
No, ma'am.
Good evening, sir.
Sir, this is Bharat from VIT AP. So
Yes.
my query is like, apart from this tools, I think we have one more tool called iFox Sim.
Yes, yes. iFoxing, actually that is for fog computing.
Okay.
That we use for scheduling, for fog computing, for resource optimization, resource scheduling.
Yes, sir.
So as far as fog computing is concerned, that is also fine. Whether so HCM is also there, but these are dedicated to specific implementation. But if we are working on IoT, then it is better to take that specific toolkit. So whether you can take cup carbon, you can work on Contiki Kusa also, or you can take this Sumo. If your work is related to fog, for example, you are creating a scenario related to a fog network. In that case, iFog sim can be done, can be taken. But iFog sim is focused to Java based programming. So everything we have to program in Java in case of iFog sim, using NetBeans or Eclipse. That is uh, that is very core to programming part. As far as these programs, these toolkits I have covered, these are GUI based. Okay, so if you are comfortable in Java, you can go for iFog sim or Cloud sim or similar toolkits.
Okay, sir. Thank you. Thank you so much. But my question was, sir, like, how can I implement my iFox Sim, because I am working on both IoTs.
Okay.
I want to use that IoTs in my iFox Sim, but I have some small issues regarding that. So can I contact you later through some emails or?
Yes, sir, definitely you can communicate by email, and I will try to troubleshoot.
Yes, sir. Thank you so much, sir. Thank you so much.
Thank you, sir. Any other query from participants?
Sir, there is Vijay Prakash.
Yes, sir. Good evening, sir.
Sir, how can I implement cloud or fog computing using IoT as well as some deep learning approach? Can it is possible with these tools?
Yes, sir, definitely. For implementation of fog, cloud, and IoT, we have to take some IoT simulator. Okay, So either you can take Contiki Kusa. Contiki Kusa is very popular tool, very popular platform for IoT programming. If you are
So what's a terminology? Contigi?
Contiki Kusa,
Okay, okay,
Kusa simulator, Kusa. And
okay,
as far as deep learning is concerned, deep learning or machine learning or AI, that is focused to data part. Okay, so whatever the signals we are capturing,
okay.
whatever data we are capturing from iFog SIM, Cloud SIM, Contiki Kusa, or whatever it is, we can use it for training in deep learning.
Sir, as you know, sir, this is the mix problem. Actually, this is the mix problem concept in which the IoT as well as I am using deep learning technique and for the fog environment or cloud environment.
Yes, sir, no problem, sir. It is better that you are working on multiple disciplines, and because more technologies or more paradigms you will use in your platform, in your implementation, it will be better. Okay,
Okay.
so if you will work on only fog computing, then it will be challengeable. It can be challenged. If you are working on only cloud computing, then you might have seen as a researcher, we
Yeah.
face a we face a very common question that lots of work is done in this area, what new you have done. But if you are creating a mixture of fog, cloud, IoT, deep learning, in that case, uh, obviously you have done lots of homework in your area, so you will defend, and
Yeah.
obviously it will be better for uh, presentation of our work. It is always advisable to take multiple disciplines in consideration in your implementation. So that is good if you are taking multiple technologies, because nowadays we are in the timeline of multidisciplinary or integrated research.
In this aspect, sir, Contigi Kuja or cup of carbon will be easy to implement.
Yes, yes, definitely. You can
Okay.
work. Nowadays, APIs are available. Most of the software gives their APIs or programming interfaces, so we can link.
Okay,
And
sir.
these are open source. In open source, we have lots of possibility to play with the code.
Yes, sir.
Okay.
Thank you, sir. Thank you.
Welcome, sir. Any other query from participants?
Thank you, Gaurav sir. It was a very perceptive session on this simultaneous tools for simulation tools for smart cities, and you have optimally described the tools, models, analysis which are needed for building this infrastructure and operational planning which is involved for the smart city planning. So thank you so much on part of the faculty development program team. We extend big thank you to Gaurav Kumar for sparing here your time and being here for two sessions. So thank you, sir,
Thank you, ma'am. Thanks to all
once again.
participants. Thanks to all participants and the organizing committee. Thanks to all.